At ProDevs, we specialize in connecting businesses with top African tech talent. Be you a startup or a corporate company, whatever your hiring needs are, ProDevs is the place for you.
Outsourcing with ProDevs means you get access to a global pool of highly vetted tech talent. From developers to designers to product people to data analysts, we ensure that the right and the best talents are working on your team and for you.
Looking for permanent hires? Our recruitment team is designed to match you with the top talents quickly and efficiently. We take care of the heavy lifting, from vetting candidates to getting the right cultural fit, so you get the best, faster and quicker.
Outsource the right tech talents, recruit the best fits.
Find your next tech hire with ProDevs.
We make tech recruitment simple, fast and efficient.
Hello everyone, welcome to our live section for today. So I'm going to briefly introduce Ebenezer. Ebenezer is a senior software engineer, team lead at ProDevs, and is known for building strong systems and shaping engineers to think beyond writing code, while focusing on problem solving, decision making, and growth. And at ProDevs, ProDevs is a talent platform designed to make hiring simpler and more reliable for companies, while also helping tech talent grow and access better opportunities. For clients, we provide pre-vetted African tech talent, salary insights, and flexible hiring options, whether direct hire, outsourcing, or gigs, so they can hire faster, reduce guesswork, and build teams that deliver. So for talent, ProDevs opens access to quality local and global opportunities. They also support career growth and connect talent to roles where their skills are actually valued. And ProDevs is built to create real outcomes on both sides. Better hires for companies and better opportunities for talent. So welcome everyone. Today we are talking about something that separates average engineers from exceptional ones, and that is how they think. This session today the topic is how to think like a senior engineer, and it is focused on moving beyond just writing code to understanding how senior engineers approach problems, make decisions, communicate clearly, and handle complexity in real-world scenarios. So if you've ever felt like you're doing the work, but you're not really growing, this section will help you see what needs to shift. So welcome everyone. And thank you also, Ebenezer, for being here today to share your knowledge with our audience. Thank you very much. So the floor is all yours.
Okay. Hi, everyone. Good afternoon, good morning, good evening from wherever it is actually joining us from. Today, webinar is going to be a very, very exclusive one, and I hope you learn one or two things from this session. All right, I'll go ahead and present right now. Do let me know if you can see my screen. You can see my presentation.
Okay. Yes.
Okay, all right. Thank you so much. All right, so today we'll be talking about a very, very exclusive topic that talks about how to think like a senior engineer. Like one of the words of the earlier founders of programming says that everything starts from the mindset. So if we can think it, we can actually achieve it. And this is going to cover up how to level up your mindset, how to solve bigger problems, and how to build systems that actually last. Not just solve a problem, but systems that actually last. Today, we're going to talk about a couple of things. The first is going to be the core paradigm shift, which is the mind, right? We're going to talk about the architectural decisions and the 10x rules. And 10x rule is something that we use so much in the engineering space. And it's something that if you want to get yourself to the point where you are not just writing code like a bricklayer, but becoming an architect of a system, you have to understand what exactly does the 10x rule means. We'll be talking about the debugging of observabilities, the multivariable trace-off triangle, which is very, very super interesting when it comes to building fast and scalability. A lot of times, as engineer, we build fast to actually meet the market of what we're trying to do, to actually hit the market faster But at the same time, too, a lot of things are actually solving on the back. I mean, scalability of that system. Will your system be able to perform optimally when you have 100,000 users as it's performing now when you have just 500 users? Just as where it comes to place. We're going to talk about the 6 pillars of maintainability, taking extreme ownership, and writing maintainable systems. All right, so let's talk about the first one. What exactly does the core paradigm shift means? The core paradigm shift means our mind, right? For a junior software engineer, we see them as bricklayers. If you want to build a house, the dirty job and the core functionalities of that job is being done by the bricklayers, by the laborers, by the carpenters that put those structures in place. But the architect sees the entire vision of the house even before the foundation is being laid. That is where the core mindset comes into place. The architect sees the entire architecture of the house. Okay, this is where the pillar is going to be. This is where the windows is going to be. Oh, if you put the window here, the ventilation might not be properly, being in place. This is where the door is going to be. An architect is someone that sees the entire vision of that particular house before it is actually being built. Why the bricklayers are the one that just go there to execute. So for you to start thinking or to shift from just being a mid developer or a junior developer to a senior engineer, you have to start thinking like an architecture. When a PR or a product requirement document is being given to you, what is the first thing that comes to your mind? Is it for me to just jump into it and start writing code, or being able to calm enough to examine and understand the overall goal of what that particular PR is trying, product requirement is trying to do, and be able to understand what are the systems you're going to bring into place? What do we currently have? Where are we going to? In that way, it guides you and actually reduce the number of code you end up writing, rather than just jumping in and start typing codes, right? So as a junior engineer always focuses on lines of code. How do I write this function? How do I make this function work? How will I be able to achieve this? How will I be able to achieve that? That is always the first mindset of a junior engineer. But to actually start thinking as a senior engineer, the core paradigm that has to happen is that you have to focus on the system, not just on your code. Focus on the system you are trying to build. The first thing is, what am I trying to solve? Okay, this system I'm trying to build is going to be solving problem that has to do with a fintech. If the fintech solution, the first thing that has to come to your mind is, which API gateway am I connecting to? Thinking about latency, thinking about brutal force, thinking about if someone comes into the system at 2 a.m. when everybody is sleeping, started brutal forcing our endpoint and was able to actually break in. That is where the focus on the system comes into place. Not just being able to write the code that says transfer 20 naira or transfer 50,000 naira to bank XYZ and the money goes through. That is function. But the system thinking side of it is, what happens if the money goes through, but unfortunately the receiving partner doesn't get the money? What happened at that point? That is systematic focusing on the entire system architecture actually comes into place. And that is what the senior engineers do, the senior mindset. The second one we're going to talk about is the measure output. Junior engineers measure output based on the speed and the volume of completed tickets. I mean, almost all engineers have deliverables and timelines to actually measure, right? Oh, you have XYZ ticket that you have to do within the space of 3 weeks or within the space of 2 weeks. But to start thinking as a senior engineer, you don't just measure the tickets that you are being assigned. You need to measure the outcome of what you worked on. For example, if you are assigned a ticket, they said, this week we realized that we have a lot of drops-offs at the point of sign-up, where some users were able to sign up successfully and some were not able to sign up successfully. It's a ticket. But the outcome is when next week they now tell you that, yesterday and last week we have 60% drop off, but this week we have just 5% drop off. That is outcome. So as a senior engineer, you need to start thinking about what is the outcome of this ticket I'm currently trying to work on. Not just what you're trying to achieve, but what will the perfect outcome of this ticket looks like if I'm able to actually execute it successfully. The third one is the instant certification. We write the code, junior engineer write the code, they test it, it worked, we are okay. But whereas in the real sense, have you tested some edge cases with that particular code? If I'm trying to transfer 20 naira and I mistakenly press minus 20 naira, will your code still be able to, will your function that you've recently still be able to accept it? Will it accept that particular transaction I'm trying to perform? If I go to your platform and I say I want to withdraw 50K and my balance is just 5,000 naira, will your function still be able to allow me go through? Those are the edge cases that should actually come into play when it comes to where it comes to, you know, understanding the system very well. But as junior engineers, as long as we write it and it works, I press 20 naira and it goes through, I mean, the function is working fine. But as a senior engineer, we are always aware of the liability of what we are doing. That means if someone tries to brute force that endpoint, will raise condition happen if I open the same browser, the same app 2 times, and I try to send 20 naira at the same time? Will your system to be able to allow me send through? Because that way is a debt on the company already. So the liability awareness is where the mindset comes into place. You start thinking of the awkward thing you think that can happen with what you are building. Not just thinking about that it's going to be a straight line through. I mean, I will press it and it goes through. But start thinking about the awkward instances of where, if it goes the other way around, do I have a system in my code to actually be able to catch this? That is where the liability awareness comes into place. The fourth one mindset of a junior engineer is the out of scope. They view architectures and defaults as someone else's job. I mean, my work is just to write the code and make it function. It's none of my business on how this is going to get to the server. It's none of my business on how this is going to get deployed. We have DevOps engineers, but as a senior engineer, you need to actually have a good understanding of how things work end to end. If your DevOps engineer is not available at 1 a.m., the server is down, will you be able to pull up to the instance and actually get your server back up on live? That is where the mindset comes into place. So for senior engineers, instead of them being out of scope, the coupled logics, designs are simple, the coupled boundaries and very clear event that you can actually easily understand. And the fifth one is over engineering. This is something that's so common within the tech ecosystem. We overly engineer a couple of things, especially the junior engineers. Overly engineer something, just a simple thing. You want to build a simple landing page. There's no need for you to connect to server or anything. Then you went ahead and put the entire Next.js framework just to build a simple landing page that you're not connected to any server with, which is something you can actually achieve with just a simple HTML, CSS, and I mean, you are up. But because we want to feel like, oh, okay, sorry for that. But because you just want to feel like, oh, I'm a senior front-end, I'm a front-end engineer, I can use React, I can use Remix, I can use Next.js, I can use Angular, I can use Vue. Then we go ahead and pull down the entire ecosystem on just a simple landing page that is not, doesn't even require any server side of things at all. That is where the idea of engineering comes into place. But for the senior as a senior software engineer, you love the boring side of tech more, and not the fancy ones. You don't really have to follow the trend. Oh, there's a new framework in town now, next 16. I think that's what I'm going to use in my next project. I need to actually pick that up. Oh, there's a new framework now, Remix. That's what I'm going to use in my next framework. No. But you start thinking about the boring side of tech. You know, the simple thing, very simple, battle-tested solutions that are very easy for you to debug. Instead of you pulling down the entire next 16 on just a simple landing page that does not even have any other routing at all, why don't you just get the Rashid with the simple HTML, CSS and push it and you are done, since you know this is not something you'll be changing all the time. So as a senior person, your mind has to be so much, you just have to make love for the boring tech side of things. I was having a conversation with a couple of my guys recently, and one of the conversations was coming up like, oh, people are really moving away from PHP. A lot of things are happening now. People are going towards JavaScript, Node frameworks. People are using machine learning. I was like, you see, these are boosts. As a senior engineer, you know one tech stack and you know it correctly. Not just being an half-baked, oh, I know JavaScript, I know PHP, I know Node.js, I know Golang, I know Angular, just know all of those tech stack. Big 50%, 50% of it. You have to be a master of one. Is a PHP you want to focus on, know it to the core depth. That if they wake you up at 3 a.m., you can actually pull up and figure out whatever code that particular production app is having within minutes. That is where the mastering of that particular skills comes into place. Are you still with me?
Yes, yes, we are. Please, if you
Okay.
have any question, you can just drop it in the box. But I have a question for
Okay.
this part. So you described junior engineers as bricklayers and seniors as architects. At what point in your own career did you consciously make that switch, and what triggered it?
I think that's what happens at one of my previous roles. So
Okay.
when I joined the company, they were more on PHP. I mean, the server side of things was built entirely with PHP. But the company has
Mm,
grew past that they now process over thousands of users' savings, interest on daily basis, and the system was unable to accommodate it anymore. So we advised that okay, let's move to a more event-driven architectural systems like Next.js. And I was just more focused on the entire migration. And we make the push on Friday, then on Sunday, out of nowhere, while I was in church around 2 p.m., the CTO just called me, hello, Ebenezer, our server is down. And I had no idea of what exactly is going on. I had to rush all the way down and I had to
mm,
start debugging. I spent the entire day from like 2 p.m. to like 6, 7 p.m. debugging, only for me to realize that it was just some edge cases I didn't catch on how I was actually connecting and communicating with the database. How I was getting information from the database and all of those. So with that, the database gets overloaded. We have a lot of relationship and query that was going up there, and that was just what's killing few of those our endpoints. And that was a shift for me. So because of that happen, I have to sit down, restructure and refactor everything around the database connectivity throughout that lines. And from there, I just take it apart of me that whatever system I have to build right now, I have to first understand what are we trying to achieve, the entire relationship between one table to another before I even start writing any code. Because with that, most of the time, by the time you go to production, we have minimal and less issues compared to when I just can't jump into the code right away and I start typing to fix the problem. Sorry, I can't hear you anymore.
sorry, I forgot to mute. Okay, so I said that's awesome. You can proceed. Thank you very much.
Okay, all right. So after we talk about the mindset, the second one we're going to talk
Mhm.
about is architectural decisions. So what exactly does architectural decision means? It means you are seeing the entire system of what you are trying to build, even from the very foundation. Let me give you an instance. Let's say, for instance, you are tasked to build a loan application, and you understand that this loan application is going to be a multi-step approval process. I mean, sales we have to approve, then they move it down to the credit system, move it down to their finance before it's not get to the maybe head of finance that will now finally approve the loan before it actually goes out. You need to understand every process that's going to happen there. There's going to be a repayment. How are you going to capture your repayment? Are you doing a direct debit? Is it that the customer has to connect their bank or their card to your system so that your system will be able to charge them recurring? Is it that you are going to have loan officers to actually go there physically to those customers to start retrieving your loan payment on that? You need to have a perfect understanding of the architectural system before you start building it, right? And when it comes to architectural decision, there are two ways. We have the two scale rules, and we have the irreversible and the reversible rules. The two scale rules is when you want to scale for a 10x load. Let's say, for example, you have a database, and that database majorly just does getting, maybe on the system, getting list of banks from maybe Paystar or MoneyPoint on any of the payment gateways that you've integrated. Instead of you to actually keep going back to those guys and calling them to return list of banks for you every time any user is trying to access your app, you can actually implement what is called the caking system. That means you call it once, you cake it to either your Redis or in memory, and for subsequent requests to that endpoint for the next 10, 15, 20, 13, or even 1 hour, you are returning the response to the user from your cake. This way, you don't write too much queries to the database. You don't have to keep calling the database. The input and output, the IO threads in your database does not scale exponentially all of a sudden. That is where the scale for the 10x load comes into place. Will your system be able to, if your system is performing fine now, you are calling page stack every time, you just have maybe just 50 or 100 users. With that same mechanism still work, by the time you start having 20, 50,000 users that actually want to connect their bank to your system, right? The second one is the architect for 100 simplicity. Architect for 100 simplicity. It simply means that you just make sure that your entire system is decoupled, not tightly coupled together. There are a couple of codes that you will open, and if you touch the authentication service of that particular backend, trust me, the email service might get affected, the notification service might get affected, and even the wallet transaction, if care is not taken, will get affected. That is where the tight scope comes into place. You have to make sure that they are decoupled. Your authentication service is a module on its own. Your wallet service is a module on its own. Your transactions is a module on its own. If you have communication, your communication that has to do with emails, push notifications, they are modules on their own. So with that way, if there's anything that has to do tomorrow, maybe change, you can even decide to say, okay, I want to change the architecture of this particular project from being modular to microservice architecture. But because you've employed the 100% principle of modularity in the first instance, it will be very easier for you to start switching things to microservice architecture. But when things are tightly coupled, then it becomes a problem. Because, I mean, if you touch this is affected, then it now looks like you are re-engineering the entire thing from scratch. That is where the architecture for 100%, 100x simplicity comes into place. Write the coupled modular boundaries, and if load jumps by 100, then modules must be simple to swap without major rewrite. If load jumps, for example, you are trying to implement a file system, that means user can upload files to your system. I mean, you can actually go ahead and have AWS implemented, Azure implemented, and Cloudinary implemented just for user to upload. And if there's any way that along the line AWS is down, your system should be able to automatically switch to either Azure or Cloudinary, and without even breaking the user flow. So that comes to a place when you have a very good modularity system. And the third one for the 2 scale rules is the simplicity scales best. Simplicity scales best. You have no business with microservice architecture when you are still trying to gain your first user. I repeat, you have no business with architecturing a system as complex microservice architecture when you are not even sure if the market fit of that particular product is something that the market is going to, love, or is something that is going to scale through in the market. Release your MVP first. Make it a monorepo. Test the market. If there is great adoption, come back into place, but make sure that by the time you are doing your monorepo, it is very, very modularized. Your host is module, your communication, your transactions, your product, depending on whatever it is you are trying to build, make sure that the system is modularized, monolithic, monorepo. Just push it to market. See how market is going to adopt it. Simple. And by the time they adopt and see that your transactions are actually coming in pretty well, then you can now go back to the ball game and say, oh, okay, I need to refactor a couple of things. This has to be there, or let me just change the entire backend architecture to more microservice, or let me just do this, let me change it to more event-driven system and all of those. But when you build simple, you hit the market first, and when you employ the architect for 100 simplicities, you scale faster. That is where the idea of the 2 scale rules comes into place. We now have the reversible and the irreversible architectural decisions. The type 1 is the irreversible one, the one day, the one-way one. It's difficult or very expensive to reverse. For example, the search of the database, right? If you build the entire system with a non-relational database like MongoDB, And later on, you realize that, oh, the performance of this thing is not optimal to what I'm trying to achieve. Then let me switch to a more relational database, like maybe MySQL or Postgres. It takes time for such kind of migration to happen. Those are the one-way, almost irreversible migration, irreversible architectural decisions. Because without switch, you cannot easily go ahead and jump your MySQL database down to your relational database. The IDs there are 100% almost extremely different than all of those. Then it becomes it. So you have to, by the time you are building the framework, sit down and understand what you are trying to build. Understand the entire thing, the entire architecture, or the entire framework of what you are going to use. For example, if I'm trying to use a Next.js for a backend system, because I feel that I need the event-driven nature of it to be able to process a lot of background work without blocking a lot of things on the way, and you decided that, okay, I think it's best for me to use MySQL, make those decisions early. It's not always easy that you build a system with Node, then tomorrow you now want to go back and rewrite it with Golang. Tomorrow you now want to go back and rewrite that entire system again with maybe PHP, or write the entire system with Python or other programming language. So these are very, very important. Even down to framework. If you build an entire system with Node.js, it might not be very much easier for you to say you want to go back and rebuild that same entire system with Next.js. So the choice of frameworks, the choice of programming language you're trying to use, and as well the choice of database are examples of the one-directional, one-way door. Now let's talk about the second one. The second one is the two decisions, two-way doors. It is easy and cheap, and it's very, very reversible. I mean, your Redis, your wrapper keys, your local class designs, the way you define your types, interface, if you're using TypeScript and all of those, they are very reversible. You can actually tweak things around. Those are the two ways. Then we now have the last one, which is the keep doors two ways. That means rely on clean interface boundaries and wrappers. That means both the type 1 and the type 2, over time, they are able to communicate together. Your irreversible ones, which is the node, which is maybe your framework and database decisions, you are able to actually have it blend so well with the one that can go either ways. That is when we start talking about the keep doors two ways open. Be able to understand the entire architecture system. Okay, this is not reversible. Okay, this I can actually change it later, no problem. That is where the idea comes into place. Then the third thing we're going to talk about is the trade-offs. What are the trade-offs? That means managing scope, cost, and value. The simple truth is there is no perfect solution. The best product out there still has one or two bugs that is actually in place or still trying to fix. There is no perfect solution. Every architectural decision has its own real cost. Every architectural decision has its own real cost. If you are building for speed and reliability, that means if you are building to reach the market fast, then your focus might be towards someone's speed and the reliability of your platform, and not really in the initial state towards scalability. That means when it comes to fast speed, that how fast can you ship to validate hypotheses or capture market fractions? That is what comes into play. You just want to hit the market. It's none of your business if it's scalable later initially, but you just want to hit to the market. That is one thing. The velocity of how you reach the market, right? The second one is the quality. How bulletproof is the logic? And what is the edge cases, coverage, and the type of those safeties? Like I said earlier, if you are building a financial app, if a user to come ahead and was able to somehow navigate your front end to enter minus within the amount and send it, your system will be able to process it so that the quality and the reliability, the edge cases, will your system still be able to accommodate 20,000 users? Where right now, you just have just 5,000 users. Those are the edge cases. That means will your server still be able to accommodate it? And the last one, which is the last multi-drivers of the triangle, or the trade-off triangle, is scalability. That means the flexibility. How flexible is your system? The truth is, most times when founders or when engineers are being pressured to build fast, we tend to go towards velocity and quality of what we are trying to do. We just set a couple of edge cases with the quality and try to actually hit the market as fast as possible. Whereas the trade-off of that is that the system might not be scalable if care is not taken. Especially with the advent of AI now, you can actually sit down over a weekend and just code off a product and just push it to market. But with that product, even though when you start creating user attractions, will the product still be able to serve your users by the time your user numbers goes to 10,000 people using the application? It might actually work seamlessly now if you have just 5, 1,000, 2,000, or even 500 users using the app. But with the app, with your product still be able to scale, flexible enough to be rewritten, or flexible enough to actually scale by the time the number of adoptions on that particular product comes into place. So if you are trying to build fast, then you might actually be burning scalability in the long run. But if you are trying to build for scalability, you might actually not get to the market faster. So when it comes to taking up the architectural decision that you want to use, depends on what exactly you are trying to achieve. And the first one I want to talk about is the debugging. When we talk about debugging, it means how fast can you pick up a production-based application, not even a local application on application or a local bug or a bug happening on a staging or test environment. I mean a bug happening on a production base, a bug happening live on a live application. That might even not be generic bug happening to all users. It might be bugs happening to some specific of users. How fast can you pick it? That is where the debugging observability comes into place. For a senior engineer, a senior person does not solve bugs. They build a system that exposes bug instantly. Your system must be able to actually pinpoint and tell you where the bug is. Let me give an instance. For example, when we're trying to hit to the market faster, we just build our application, we build the backend system, and we push. No observability, no Promistos, no Grafana, no Hotjar, no Sentry to be able to track whatever bug is happening in place, or the least connect your server to maybe a Slack channel to just prompt you whenever there's any error, or connect your server to maybe if you have Zoho-Click, a Zoho-Click just for you to be able to get real-time information of what is going on the server. Most of the times, I always do this for 500 and above error. When the error I'm coming back from the back end is 500 and above, definitely something might not be right. Either a database is actually hitting the limit, either one of the third-party API we're communicating with is not responding as expected, or something is just not right. Errors like that, do you have a good observability in place to be able to catch them faster and better? To be able to catch them faster and better. So that is when senior engineers now start thinking about, okay, I think I need to actually have Grafana in place. I need to connect my Promistos. I need to connect my Sentry. Or if possible, I need to connect maybe an Hotjar, or if your company is using Slack, just create a channel on your Slack channel, connect the Slack channel to your server, and just send whatever 500 and above event that is going on your server to that Slack channel. By the time you are sending in, send the endpoint, send the payload of whatever the query the user sent. In that way, you'll be able to use that to actually reproduce the error locally on your end and know what to fix. If it's a query, send the query down, send the parent, capture the entire error and the error stack of whatever it is that the user got at that point. Capture the entire error stack at that point. Send it down to yourself, or if you're using Grafana, go ahead on Grafana and just check it out. If you're using Promistos, just check it out. With that, you can actually solve a bug that will take you 2 days or even take you 6 hours within 5 minutes. That is where the debugging observability comes to place. They think about the entire system, not just about writing code. Right? The second one is aggregated health metrics. The senior engineer will track the system metrics, the CPU loads, the API 500 error count, like I just discussed, the queue depth to alert if a failure occur. It is very important. We sometimes process a lot of requests in queues. This happens so much in systems that have, especially in financial systems, where we have to process interest or process savings interest or process investment interest, or process transactions underwood for users, and you just have to put them in queue, using either a Redis bool or using either a bool queue system, or connecting it down to Redis, and just for you to be able to process it underwood. These things actually sometimes fail silently. They fail silently. You killed it. You think the next clone is going to pick it up. It might never get picked. In that case, do you have a system that can actually track those silent errors? And I can tell you that the silent errors are one of the hardest errors to trace for a developer, because you might not even be able to pinpoint where exactly the error is coming from. And it might be working on your local machine perfectly fine, but just that the error is failing silently on your server. So having aggregated health check for you to be able to know within 2 to 3 p.m. was my server up? Okay, my server was down for 5 minutes. Go to your server, check between 2:30 to 2:35. The server was down. What happened at that point? That way, it guides you to say, oh, the server got overloaded. I was processing a lot of jobs on the background, and that was what killed the server and restarted the server. And all of those information we give you guys to be able to build not just an application, but a good architectural system that can scale the test of time. The third one is the event details log. Capture explicitly state tracks and field transactions, data parameters. Just capture everything. Why it fails, where it fails. Those information are very, very important. Why it fails, where it fails, and what was sent when it fails. Where it fails is it the endpoint that is failing? Where is the endpoint that is failing? Oh, okay, first class user, first class API, first class version 1, first class product, then get product. That is where it fails. Why it fails is the start error that you got back at the point of failure. Why it fails is because data ID is undefined. That is why. Now, what was the data it was holding at the point into failing? What was the argument? If it's a parent or a get request, was there a query parent that was sent? What were the queries? Those are the information, the detailed error log that you will need much faster. That is the request journey. Be able to trace the request journey. The user logs into the app, and once he logs into the app, he hit the login endpoint, the login endpoint, then he hit the transaction endpoint to get all transactions, then he reset the transfer endpoint. Okay. After he did the transfer endpoint, then he hit the send money endpoint, and at the send money endpoint, two things was there. He entered this particular information. The user journey, the user logs on the back end. In fact, most times we build a systems where we keep a log of every user endpoint of user journey on the app for 3 months. So that way, if anything breaks, and we are from our observability, we are able to figure out, oh, okay, this is where it breaks. Then we go to the user journey. What was the user journey down to the point of failure? That way, it gives us a lot of in-depth on, is there any place we need to optimize? It's possible that the user that is having that particular issue has done a lot of transactions on the app, and your database is not optimized enough in a way that you have a lot of relationship here and there. And now, because the user has a lot of transactions, you now start connecting. Left join, right join, left join and map one, left join and map many. Getting a lot of information from different tables, and that is why the user is having that error. The request log journey will be able to trace it out for you. That is why it is important. All right.
All right. Thank you so much. So before you continue, let's quickly take this one question. Light Codes asked, how do you balance speed, flexibility, and reliability?
Okay, yeah, that's a very good question. And it's a very tough question for engineers, especially when the PM is on your neck to say, no, we have to make sure this feature is shipped to the market next week. Then you are on the pressure to deliver, and you start thinking about the functionality of that particular feature and not really about the scalability of it. So when it comes to how do we balance it, one, most of the times what I always do is, if a PM is telling you, oh, this feature has to go to market next week, and you feel your current architectural system might not be able to accommodate it by the time you start seeing a lot of user adoption on that particular feature, have a conversation with the PM. But If you feel you guys are still very much in the MVP state, nothing so much is happening right now, but users are actually requesting for this feature and feel like, oh, this is what they actually read right now, then you might trade scalability for later. But when trading scalability for later, make sure that what you are building is modular enough so that when things change in the future, you can actually tweak it as well. So how do we now balance speed, reliability, and scalability is when speed is in place, the reliability part of it should be built in a way that we have the scalability in mind, that if tomorrow something change, what I'm building right now should be able to accommodate it. If, for example, you have a couple of things, maybe your function now is taking, just for an example, you have a function that is doing transfer money, and the function is just taking the amount, the bank code, the account number, and maybe the user ID of the user that wants to transfer that particular money. Your system or your function should be able to say tomorrow, if we need to have a check for is the user account blocked, your system should actually be able to accommodate it and not wired in a way that if tomorrow you need to have to check the user bank account, then you now have to go back and start writing the entire code from scratch. So when building for speed, make sure that your reliability is functional enough in a way that it has the scalability of that particular feature in mind. I hope that answers your question.
While we're waiting for his feedback, I think we can continue now.
Okay. So we're still on the debugging mindset now. We've talked about a couple of these things. Observe the systems with telemetry. I mean, that is when we talk about your Grafana, your Postman stores, and all of those, and all of the rights. Have system boundaries. Be able to track what's happening on your database, what's the maximum request that is going in, what is your input and output request, and all of those information. Build forcible hypotheses. That means under concurrency. If you have 500 people trying to get information, sending get requests to your database, your database to be able to accommodate it. Those are what I mean by the forcible hypothesis. And there's always a way you can actually stress test your endpoints. I always say, always make sure that, especially when you know that your user number has grew more than 20,000 people using that particular product you're working on, please always stress test your endpoints. If 50 people are trying to hit that endpoint at the same time, we still be able to actually perform optimally as expected. Then also run targeted small experiments. Apply the minimum patch needs to approve the theories and observe the measures again. Run small experiments. Stress test it with 20,000 people testing your endpoints. Stress test it with 50,000 concurrent requests coming. Stress test it with 10,000, 5,000. With that, you'll be able to know the number that you can take up to and start deciding, okay, is it time for us to scale horizontally or is it time for us to just scale vertically? That is when the decision will actually come into place. And code regret safeguards. You just have to code regret safeguards. That means lock down the solution, understand the different things that you have to have in place, and even before the error starts coming into place, it makes you a step way ahead. All right. The fourth one is extreme ownership. A senior engineer takes full ownership of the product. They are not just interested in writing the feature. They are interested in what is going on in the entire life cycle of that product. That means being able to take accountability. I know it's tough. Accountability is something that developers always run away from. Where you know that, hey, if I take accountability now, if this thing breaks tomorrow, they will hold my neck. We always try to avoid that side of things. That side of accountability. That side of being saying, if it's breaking, go and call XYZ developer. If the authentication is not working, go and call UPC developer. You just have to take accountability of that particular feature of the product you are working on. So that if tomorrow they said something is breaking on the side that you've worked on, you should be able to actually stand up to it and work on it. That is when you take the extreme ownership of that feature. In big organizations like the Metas and the Facebook, people take accountabilities of whatever feature they are working on, not just being a developer alone. Even if you work in those organizations as an intern, you have to be able to take full responsibility and full accountability of whatever it is you are actually working on. So we are dividing into two. The first one is the extreme ownership and bridging the PM gap, right? As a senior person, a seniors own the production outcome. If it compiles locally, it might not compile on your server. Then in that case, you will own the extreme outcome of the production outcome. It's working on my local. Is it working on your side on the server as well? Is the expectations or the behavior of that particular feature you just worked on local? Is it the same thing that is happening on the live server? That is when you own the outcome and not just the task of what you are working on. They also talk about the proactive risk management. A lot of times, based on my experience, a lot of features will be pushed to you as a developer. You know, on the business side of things, they just want to push a feature out and make money, right? But you as a software engineer, you have to understand the risk level of what you are building, right? So that is when it comes to play about the monitoring the security vulnerabilities, the load volume, the transaction integrity checks, the proactive before incidents even start happening. A good example is there are a lot of times where on the business side of things or on the management side, they just come to you and say, oh, we need to have this feature pushed out. But you know this feature, if it's being pushed out right now, based on what you have, a lot of things might actually get broken, right? Because the foundation was not strong enough. You should be proactive enough as a senior engineer to actually tell them, to actually have that conversation with them that, oh, what you're trying to do is nice. I love it, but we are not at the very best position in our current product lifecycle right now to push out this feature you're trying to work on. Then the last one I will talk about is the elevating others. That means multiplying your team throughput, conduct tip, PR reviews, mentor the juniors, and laying clear architectural standards. As a senior engineer, your work is not just writing the code. Lay structural architectural standards. That means before any junior engineer push to you, there must be PRs. Raise the PR, have a review of it, and during the reviews, if you see any trace-offs or any technical debt, it happens a lot where probably a feature a junior engineer was working on, you have a function that can actually do a couple of things that you now goes ahead and write a different set of functions for already. This can only be cached during the PR review session where you are reading through the code. So that means that is the time you are not just a senior, but you are also elevating others. You are also building the next generation of tech, the next generation of senior software engineers, the next generation of engineers that will be so much heavy on architectural and build scalable systems, right? And the second side of things is bridging the PM gaps. That means the PM will always come to you with a PRD of what they want to build. Oh, okay, we want to build this app. We want to make sure that this app, by the time users click on this button, they can apply, and by the time they apply, it does this, it does that. But you are going to go ahead and translate that product or that PR to code, you should be able to talk and talk about the trade-offs. Okay, this is achievable, but I think this might not really be necessary. I think this might not really be necessary. For instance, let's say you're building a product and the PRD that you are being given says, oh, user will not need to enter their password. User will just need to, send down emails to them. Just whenever the user comes to the place, ask for them to enter their email, send an OTP code to them, and just tell them to log in, and that's it. No need to enter password. Sounds good and sounds sweet. But at that point, you now have to start having conversation about a couple of things with them. Conversations around, please confirm if you can see my presentation. Okay. Conversations around which email servers are we using? Will the email server be able to send you other emails like Yahoo, Google Mails, Alt Mails? Because we have some mail servers like Mailgun sometimes have issues when it comes to delivering emails to Yahoo Mails. Then in that case, if it is Yahoo Mail, what are we going to use? What's going to be the trade-offs? These are the real conversations that actually comes into place when it comes to explaining the concept of not just being a developer, but the PR that we are being given, we are having an in-depth conversation on it. The second one is to present scopes and trade-offs. You are giving the scopes. Don't just talk about scopes, but also at the same time, talk about the trade-offs. Talk about the trade-offs. Provide PMs with clear levers. We can launch manual renewals by maybe Tuesday, but for automated subscriptions, then that can be done in 3 weeks. Give them clear levers. Provide the scopes of what is achievable now. Okay, for this MVP, we don't need to actually charge customers on monthly renewals. Let's just do, maybe one time off for now. Then in 3 months time, we can have clear that kind of conversation. Have it clear and well as stated. And the last one here is offer alternative solution. If plan A does not work, then plan B will work. If we are unable to process our loan repayment via Paystack, then we can connect to Mono. We can connect to this. We can connect to that. That is where alternative solution comes into place. That means never reject deadline by saying, oh, this cannot, we cannot achieve this. We cannot achieve this. But you can say, okay, we'll be able to achieve this on Friday. Why this will be achievable next week, Wednesday. A senior engineer doesn't outrightly disregard the entire solution, but you can say this will be achievable on so state. Why this we can push it up to a couple of days after that. Then the last one on this particular regard now is the mental blueprint, which is engineering is not just about typing, but it's about architecture structuring. Like I said earlier, engineer acts like a bricklayer, they focus on the entire code base, while a senior person is a senior engineer that acts like an architect, understanding the entire architecture of whatever it is that it's building. And like one of the founders of Python says, he said, code is read far more often than it is written. Code is read far more often than it is written. And that's what is going to lead us to the last section of this webinar, which is also talking about maintainability. Maintainability is not a feature you add at the end. It is a discipline baked into every decision. Your naming, your structures, your tests, and the courage to say, no, this is too simple. If you, as a senior engineer, if you are scared of touching a file or a line of code, then the code is not simple enough, because tomorrow it can actually break off. Okay, so what is the last phase, which is the 6 pillars of maintainability. As a senior software engineer, you have to start thinking about the maintainability of the system you are building. If you leave that company you are today to company XYZ, will the products you left behind in company ABC still be able to survive without you being there? That is where the understanding of maintainability comes into place. And the maintainability has 6 pillars. The first one is clarity. The second one is simplicity. The third one is testability. We have the documentation, consistency, and modularity. Let's talk about the first one, the clarity. Make your naming very simple. There is no point saying you add the product, you add a function and say get data. The function, the name of your function or the variable of your function is saying get data. What kind of data it is getting? Is it product data? Is it wishlist data? Is it sales data? Is it transaction data? Let your naming be very, very explicit. That is when the clarity comes into place. If the function is saying get transaction data, write it, get transaction data. I've read a couple of code over time that some codes will even be written in local dialect and some variables will be named in local dialect. And you start wondering, what exactly is this? Let your naming variable to be very explicit so that the next person coming into place, even without reaching through the line of code, from the function they could be able to tell this is what this function is doing. The second one is one function, one job. One function, one job. It's not that you write a function that will fetch information from backend, and still in that same function, you are still transforming the data again. It's a lot already. Have the function that fetches the information, have a method that fetches a function that fetches the information from the backend system. You can call it get transaction data. Then just have a method or a function that actually does what? That actually transforms the information from the backend to a readable one. Maybe you now want to start using your movement to format the timing. You want to start using your number formatter to actually format the numbering as a proper currency. Then you have that as a different one. Not having the fetch information data and also at the same time the transform and the transform function. Everything happens in the same thing, right? The third one is the obvious data flow when it comes to clarity. Obvious data flow. A reader should be able to trace how data moves from input to output without guessing. If your function is having an argument, even me reading through your code, I should be able to understand that, okay, this function is taking argument amount, argument currency, and argument the user ID to perform maybe a debit transaction, for example. That is clear user information. Not saying function transfer. Then you now say X string, Y string, Z string. What is X? What is Y? What is Z? The next developer coming on board will start wondering, what is X, Y, Z in this code? It should be very obvious and be able to understand the data flow in your function. And the last one is no magic numbers. No magic number. Let's say, for example, you are trying to call, maybe process some jobs under wood, but you know that sometimes it might fail, and you have to have a max retry. Name it. Max retry is equal to 3. It's a clear number that you are saying, okay, you want to retry this particular queue at least 3 times before it can be counted as failed. Max retry 3. Not that you now go there and say XX 3. Then you now start wondering what exactly is XS in this line of code. No magic number. If it's the max retry 3, name it to be max retry 3. Not just missing 5 from everywhere. And I start wondering what is 5 doing in this line of code. It can become problematic for the next person. That is where the idea of clarity comes to play. Write code for woman. Who is going to read the code? Write code for woman, not like you're writing. Machine is going to transcribe it, but at least write it. Machine is not going to be the one to start reading it. Humans are the one to read it. Write it in a way that the human, the next person reading your line of code, will be able to understand. That is where the shift is happening from just solving problem, but understanding that my code has to be clear enough for the next person to understand it. Like the second one is simplicity. The second one is simplicity. We understand, we know that you're a senior engineer, we know you can write code, you know we are a senior person, but at least make it simpler for even a non-technical person to be able to read it and understand. Look at this line of code that I just taken as an example now. I just want to write something that will just do a simple reduce function. And I say const r is equal to r dot reduce, then you start seeing A and B, then B dot ID, and you start wondering what exactly is R doing there? What is the function of AB? What is the function of B dot? What is the function of V? It can become confusing for the next person to understand what you are even saying in the real sense, right? But your code should be clear enough that when I read it, come multipliers and the user coming in and the user ID, even a non-technical person should be able to say, okay, this is what this line of code is doing. That means your code should be simple enough and to be clever all the time, not just being complex and saying, oh, I write that function. That function, I'm the only one that understands what I'm doing there. If you are the only one that understands what you are doing there, then it is not a system. It's a problem in disguise. So the shift always comes as a senior person where you just enjoy simplicity, not just being, oh, I'm the one that wrote it, but you just enjoy that even a non-technical person can read the code as if you're enjoying it as if he's reading a novel. That's where the idea of simplicity comes into place. The third one is testability. Is your code testable, or you are the only one that can test it? There are instances where a QA engineer will have, if a QA engineer does not reach out to you, can he or she still test the feature you've worked on? That is where the idea of seniority comes into place. Does your QA engineer have to reach out to you and tell you, at least, what exactly are you trying to do here? Before he understands the feature that you've implemented, then that becomes a problem, right? If it is hard to test, it is hard to change. There's no doubt about it. If it is hard to test, the code will be hard to change. And if it is hard to change, it is commotion in disgust. Because in the future, if something breaks and you now have to go back and read that line of code, can you change it? Can you modify what you've written before? That is where the idea of testability comes into place. A good test case to test the next developer exactly what the system is supposed to do. Do you have that in place? Can your unit test, if I run a unit test on your line of code that you've written, will it pass? Those are some of the things. Then test the interface, not the internals. That means test and check how code works, breaks with every refactor. There are some instances where a function is working before, but because you want to add just one more argument, the entire function collapses. That is what happens when it is hard to test. Because in the real sense, you can't change it, right? And the last one is, when it is hard to test, then the design smells. That means when your code is hard to test, go and check your architecture. It is not following the right principle. The fourth one is documentation. Is your code being documented? A lot of us always, especially very common with the junior engineers now, you just write a function and you say this function wants to get transaction from the backend, get transaction, right? And you just go ahead and write your function. No documentation of saying this is get transaction, what is it doing? What argument is the function expecting? What is the function going to return? Those are some of the informations that is necessary so that the next person coming on board will not have to go ahead and read your 450 line of code before you can understand what you are doing there. But if you have the proper documentation, maybe on the function up there, in the real sense, you did not even abstract the function very well. You are doing a lot of things on the same function. It is not properly documented again. Now, the next person coming up to take up that project has to go into the code and start doing it one line after the other. And now, your one function, transform user, is having like close to 450 line of code. Then the next person, instead out of his productive hours, has to read 450 line of code just for him to remove a if and else statement. That is what happens when the documentation is hard. Explain the why, not the what. Explain why it is happening. Why are you doing this? Not just what it's doing. Why are you doing it? Right? Look at this now. A good player will say, retry limit is DRE. Beyond this, downstream service degrade. That is why the retry is set to 3. That means, for example, your system, you know that if you put this retry of your queue to be 5 or 6, the downside stream might actually start degrading and the system might have to force itself to go down and go up. Maybe that is what your function is doing. Add the why. You can see that there's something called the incident report, maybe 2024, 2023. Add the incident report that actually caused you to make that decision. That is where the senior engineering level comes into place. Not just going and then I just write the increase function or write whatever it is you want to do. Add the why you are actually doing this. The fifth one is the consistency. Can I predict your line of code? Is your variable written, if you are writing it with Pascal, is everything written with Pascal all throughout? Or some is with Pascal, some is with snake case? Just choose one. Make sure that your code is so consistent enough that if any team member is written it, they can easily say, no, this code is written by developer A. No, this code is written by developer B. And no, this code is written by developer C. That is where the consistency comes into place. Because you've actually proven over time and say, this is the pattern that this person follows. His code always follow this pattern. That is consistency. How do you write your naming? Do you use Pascal or namespace? Not that you write up, conjugate user, snake it. You now go down, conjugate transaction, Pascal. Then it starts getting confusing, right? That's where the naming convention comes into place. Linting or formatting. Have a proper writing linting style. Are you using ESLint? Are you using Prettier? Just have a proper linting style. Error handling and pattern. We have a lot of people, some people just prefer using try and catch whenever they want to just catch error. try catch and finally. Why come in the real sense, they have an abstract to actually make that API call. They have the try and catch and everything there already. And throughout the entire code base, you just see async and await because they have a global general cache system somewhere that whatever error is coming from the backend, they can easily catch it there, right? So throughout their code base, you just be seeing async and await, async and await. They are not even really bothering themselves about the error because they have a general API call that catch the entire whatever error the backend is throwing, they are catching it and just popping it somewhere else. Your error handling pattern has to be so consistent that if I'm reading your code, I can say, no, this function is actually written by developer A. No, this error method is actually written by developer B. Be very consistent with it. Not that everywhere you are going to, you are just going to try and catch. Every function, try and catch. Every function, try and catch. It's because programmatic as your product or feature of what you are working on grows. Then the last one here is the file and the folder structure. How are you foldering your stuff? Folder structure is a conversation for another day. A lot of times we care less about how we folder our project, and in the long run becomes a problem, and we start finding stuff here and there. If you are building a backend system and you know you have to follow the modular way, let it be modular. If you are in authentication, your auth will be there, your entity inside the auth, your user entity inside the auth, user service inside the auth folder, user controllers inside the auth folder, so that tomorrow if they say something is breaking, you know the folder to go to actually adjust and not just start finding things here and there. So, and the last one is about it is modularity. Modularity means that small, focused, and replaceable units. Is your app modular enough? Look at the schema of diagram that I show here, for example. Now, we have the API gateway, we have the database layer, and we have the caking layer. Each of them has a module. Is the app modular enough in a way that it is loosely coupled? It's not tightly coupled together. Imagine you have the API gateway, the database, everything happening inside the API gateway. Then tomorrow, you have to make changes to your database or something has to happen on your database level. Then, because of that, the entire application, because the API gateway is connected to what crashes. That is what happens. Have your authentication service, have the users, have the payment modules, have all of those ones. Then have your gateways, have your database layers, have your caking layers, and just have it all connected to the app. That means all of them are tightly coupled. They are not all bundled up together. So at the end of the day, if there's any change you need to make use of or do tomorrow, you can actually go there and get it done. What is now the real cost of a maintainable system? If your system is maintainable enough, it saves you 42% of dev time. This was based on research from some developers from Meta, and they realized that by the time your system is very maintainable in the initial phase, most times developers are not spending time debugging. They are spending time building features. They are spending time architecturing solutions. They are spending time implementing what needs to be done and not spending time fixing bugs on existing application, right? Then the second one is that it is 10x more expensive to fix a bug found in production than catch it in development. It is always more expensive to fix a bug in production than you actually catch the bug when you are working on it on development phase. And the last one is 60% of bugs in large systems comes from modifying existing hard to understand code. Like I said earlier, 60% of bugs always come from regression. That means the feature was working before, but because the feature was not implemented correctly and you try to abstract or either abstract or implement something new on that existing feature, it breaks it. Then you now go back to the drawing board again, try fixing the entire system that you built earlier. So 60% of bugs over time on live system is always come from modifying existing features, and those hard to understand code. Like I always say, if you are working with React, if your line of React GXS file is going more than 400 lines of code, break it down to another component. You have no business where I enter your code and your product information, your product details code is like 2,000 lines of code because you are doing a lot of things there. Then you can actually break it down. Break the maybe see more product as a component, break the maybe product information details and the images at the component, the add to cart, the increase cart, break it at the component and just bring them all together into the product detail page. By the time you do that, your 2,000, 3,000 line of code might actually get reduced to maybe just 400 or 300 line of code. That way, if they say tomorrow, we can add to cart, you know the component to go to. Tomorrow, the CMO product is not returning the right thing, you know the component to go to. Just go there, pass the props from your product information that you fetch from the backend, pass the props down to where you are.
Can you hear me?
Okay, so like I was saying earlier, technical debt is not just a metaphor. It is interest, and you have to pay it for every new feature, every bug fixes, and every onboarding sessions that compounds daily. If you have great technical debt in your product, it's not a one-time go off. If you are not careful, you pay the interest, which is the stress on getting that fixed on every new feature you're trying to push on that particular product. So, how can we start today? How can you start thinking like a senior engineer today? How can you start thinking as not just a developer, but an engineer today? The first one is just go through those your existing project that you have working on right now, and find those naming conventions, those naming variables. Just start rewriting them. Just write. That means start with what is already in front of you. One better name, seed a culture for clarity. Rewrite those variables. Those variables that you name get data, whereas in the real sense is doing get transactions. Rename them as get user transactions instead of get ordinary data. The second one is execute one function, 20 lines. That means if you can't describe what the function does in one sentence, it is too much. If you can't say, what does this function do? This function is what I use to make a transfer. Okay, this function is what I use to make a transfer, and after the transfer, the same function is also what I use to, okay, after the transfer, I call the communication endpoint, and my communication endpoint is what I use to send notification to the user. Chicken now. You know, these are clear, actionable conversations, right? Sorry, okay. Yeah, those are clear, actionable functions. The function is doing transaction. After performing the user transaction, it sends the communication that transaction was successful. Easy. But not that inside the same function, you perform the transaction. Inside that the same function, inside that the same function too. You start checking, check what's the country of the user? No. Or you start checking, does the user have enough balance? Does the user have X? Does the user have Y? Those ones to be an abstract function on their own. You should have a function that check for user balance. You should have a function that check for, okay, is the user account active or is that blocked already or cannot perform transaction anymore? Those should be different functions on their own, not having the entire function, everything all together in one place. So that means if your function cannot be explained within one line or two lines of code, it's time for you to start breaking it down. Start thinking about the entire system and not just solving the problem that you have actually been asked to do. Thirdly is go to those projects, start writing tests. Those tests that you've run away, those jest tests, those automated playwright testing that you've run away from writing. Start going back to them and just writing them. Start writing tests for your endpoint. Class all edge cases. If writing the test is hard, that is data. Use it to simplify the implementation. If you can't write the test easily for you to actually run, then that means the function might actually fail in some instances. So go back and write those tests. The first one is add a comment explaining a why decisions. Add a comment explaining a why decision. See, most of the time as developers, we find ourselves that a function that you are the one that write the code in January, then a feature you have to implement that require you to go back and touch that file. Can you still touch the file in 6 months later without you breaking what you already implemented? That is the problem. So for you to actually avoid this, ensure that you add comments to your code. Add comments so that the next person coming in place can actually know, okay, I did this because of this. A good example is there was a time in one of the companies that we're working with in the past. So for every user transaction that happens, especially when it comes to bills payment, we're actually processing, what do they call it now? I'm trying to remember the name of what we call that thing. Yeah, like cashback for the customer, right? And that code was working fine for like 6 months. But after 6 months, we are asked to say, okay, we don't want to give cashback to customers for now. So let's go and remove it. Instead of us to go and take it down, because we know businesses for sure, businesses for sure can come back tomorrow and say, oh, we want to start giving cashback again. We comment out that line of code, and you now write a comment on it. Commented out on maybe 29th of May 2026, because business decision stops cashback giving on transactions. That is enough. The next customer coming on and reading that particular function will be able to know this function was written before, but it stopped on so date because of this. That's some of the powers of comments. Write comments to your functions. Write comments to line of code that you feel it's weird, and the next person coming on and start thinking, what were they trying to do here? And the last but not least is delete dead codes. We sometimes leave code on our code base that we feel, I'm going to use it tomorrow, I'm going to use it tomorrow, I'm going to use it tomorrow. Where we might never use it again till eternity. Like they always say, they will say, it's because of a madman does not know how to leave things and just move away. That is why its load and packages is always very many. We keep a lot of load and packages of code that you might not never use, at least for the again in the code base, because you are thinking, I don't want to stress myself tomorrow to start rewriting this thing, Daddy. If you feel that this feature your product has scaled away from it, then delete those codes. Unmaintained code that stays in your code base becomes a problem in the long run, because the next developer coming in place will now be afraid. If I touch this code now, I don't even know what the code is doing in the first instance. I don't know if they are using it or not using it. It becomes a problem, right? So those functions, those codes, those lines that you're no longer using, today, start deleting them. And to wrap this up, I would say the mark of a senior engineer is not how much code you have written. It is how little needs to be rewritten. I say it again, you being a senior software engineer doesn't depend on how much code or how many lines of code you've written, but it depends on how little effort needs to be applied to that function or to that feature when it's gone to rewriting those codes. So to wrap it up, like I said earlier, it's not a matter of how much line of code you've written, but it's a matter of how little effort it needs for that code to actually work seamlessly without any issue. I think from my end, that will be all for today. I'll be open to questions. Thank you so much.
All right, guys. If you have any question for Ebenezer, please kindly drop it in the comment section. But I have a question for Ebenezer. I wrote it down here. Hold on. Okay, so my question is on extreme ownership, right? So you said that extreme ownership means owning outcomes, not just tasks. But in an environment where specs are vague or requirements keep changing, how do you own outcomes you couldn't fully control?
Okay, so one of the ways to actually own outcomes you cannot fully control is
Okay.
have the conversation with them.
Mm.
Have that particular conversation. Even before you go ahead to start writing code or to start implementing anything, have that conversation with them. Based on experience, I realized that sometimes when business side of things sees your own point, they might not accept your point in the first instance, right? But if you don't accept
Yes.
the first instance, go ahead, implement whatever it asks you to implement. Then when they now see the lapse, the next time you are advising them, they will never argue with you anymore. Then they will say, oh, the last time you had a conversation with us about this. So if you know you can't not fully control the outcome, most time for the first time, have the conversation. If they're pushing back on it, go ahead with the implementation. But by the time they see the lapses of, oh, he actually talked about this the last time, then they might actually call you. This is what I've happened to me over time. They will now call you and say,
Yeah,
"Oh, we are so sorry. You actually make method of it. So what do you think we can do now?" There's nothing you want to say after that time. They will be 100%
exactly.
listening to listen and follow the way. So that is when you are not just being a developer, but you're actually owning both the outcome and whatever it is that is happening on that particular feature you are trying to do.
Yes, you've been justified. I like that. Thank you so much. Okay, so I have one more question, and then if there's no question from our audience listening, then we'll just call it today. I think we've actually taken so much of their time, but it's a really it's an enlightening section, and even me that I'm not a developer, I was able to gain one or two things. So
Yeah, thank you.
the last question I have is, when you're stuck on a bug for hours, as junior engineers rather, and you know you're not able to figure it out like as fast as you wanted, so the temptation is always to just move on. So what's the habits a junior engineer should build right after solving a bug that separates them from the crowd?
So one thing that junior engineers mostly do is if they have a bug to fix, then they sit on it for hours just trying to make sure, no, I have to fix this thing. 6 hours, I still on it, 7 hours. Based on my experience, most of the time, any bug that I'm not able to fix within 1 hour, I just leave it for that time.
Hmm.
Leave it off, take your mind off the entire work system. Thank God for the advent of new tools like AI now. But gone are the days, I mean, it's either you stick with Stack Overflow or Google. If Google is not giving you the answer, just know you are in for it today already. But now we have the advent of AI that you can just copy the error and send it to him, and AI will tell you, no, change it, change it. But in those days, right, there's no AI. So if you are unable to find it on Stack Overflow or Stack
Mhm.
Exchange or Google, then just know this bug, you and the bug is on a long journey. So based on time, what I always do is if I'm unable to fix the bug within 1 hour, I just leave it. Either I'll focus on something else. I mean, if you have other feature you're doing, just go ahead and focus on that for now and come back to it. Based on experience, most times around 12 p.m., 1 a.m. in the midnight, your brain is so calm and relaxed. You're not thinking about anything so much. Go back and pick up that thing. You will be so surprised that everything, the entire you had for like 6 hours throughout the day was caused by just probably a comma or a naming syntax on a variable that you send that you are not sure you didn't catch on the other end, or something just very minor. But sometimes the longer you spend on trying to fix one bug at a stretch, the more daunting and draining it becomes to your mental health, especially to your brain. You might not really be able to figure it and think it right. Most of the time for me, after spending like an hour on bug and the solution is not coming forth in the days, I just leave it or focus on something else. You can even take your mind out of code. I mean, go out, just have fun, then come back later, and you'll be surprised that the entire issues you've been having was caused by just probably an uncached argument or a variable that you did not define somewhere, and that solves it. But by the time you are solving it, make sure you learn the lesson. The lesson here is learn why it happens, so that tomorrow, if such kind of bug you are facing it, you are easily catch it and be able to get it fixed. Which is one of the issues with the advent of AI right now. We fix bugs these days that we don't even know why it happens or how it happens. But AI got it fixed for us and we move ahead. In that case, have you learned? No. Because tomorrow the same bug will still happen and you will still have to prompt AI to fix that same bug you fixed yesterday for you. So in that case, always make sure that you pick up the learning process. Senior engineers using AI these days don't just use it. We use it with tendency of it fixed the bug. You read through the code to see what was fixed and how it was fixed, so that tomorrow when you actually have to attempt it, you don't have to send it down to AI again, and it increases your knowledge gap. Thank you.
All right. Thank you so much. Thank you, Ebenezer. I really appreciate it. Okay, so as we wrap up, let me just like go through this again. So there are a few things that I was able to take away from our section today, and these few points. The first one is that growth as an engineer is not just about writing more code, it's about thinking differently. And we also talked about shifting from a bricklayer mindset to an architect mindset. That is seeing beyond just tasks to systems, outcomes, and real impact. Um, we've also touched on making better decisions, understanding trade offs, and knowing that there are no perfect solutions, just the right decisions for the moment. And we've gone deep into debugging with intention, not guessing, but observing, testing, and actually understanding what's happening under the hood. And then the last one is maintainability, writing code that someone else can read, understand, and build on. Because at the end of the day, code is read far more than it is written. And the final line is what Ebenezer, just used as a topping on the cake, which is the mark of a senior engineer is not how much code you write, but how little needs to be rewritten. So I'm just going to leave you with this as we go into the new week. Start small, rename something, simplify something, think a little bit deeper before you build. And I want to say thank you so much for joining us today. We
Thank
appreciate your
you.
time. Thank you to everyone who tuned in. We also have another event upcoming. Please make sure to follow us on all our social media platforms so that you're going to get like first-hand information about webinars like this that you can benefit from. We look forward to to having you for our next webinar. We have one coming up on June 12th. So we hope to see you there. We're going to drop all the details and information on the ProDevs Slack channel for our tech talent, but we're also going to be posting it on all social media platforms. So be rest assured that you're going to get all the details that you need for our upcoming webinar. So thank you so much. Thank you, Ebenezer. It's so nice to have you here today. So
Thank you. Thank you so much.
I guess it's Friday, so have an amazing weekend.
All
Yep,
right.
yep.
Thank you. Thank you, guys. Bye.
All right, thank you, everyone. Thank you, guys.
Thank you. Bye. Yeah.
Bye bye.
Since we're familiar with the outsourcing community, it's the fastest that we have.